Welcome back to E-Chemistry presented by
Welcome to E-Chemistry class of Fatima Convent High School, presented by myself, Dipali.
Fatima Convent High School, myself Dipali. We continue with Class 10, Chapter 1, Chemical Reactions and Equations. Now let us look at few activities which will give you a clear concept about what are chemical reactions and chemical equations. That is what our chapter is about. In this activity, we are taking a clean magnesium ribbon about 3 to 4 centimeter long and rubbing it with sandpaper to remove any other oxides on it. We hold it with a pair of tongs and heat it on a spirit lamp or a burner and collect the ash so formed in a watch glass as shown in the figure. Burning the magnesium ribbon, keep it away as far as possible from your eyes because it can cause a dazzling flame and damage your eyes. Let us see what conclusion we come to from this activity. From this activity, we can conclude that when magnesium ribbon burns, it burns with a dazzling flame and changes into white powder, and this white powder is magnesium oxide. It is formed due to reaction between magnesium and oxygen present in the air. This can be symbolically represented as 2 mg solid plus O2 gas gives 2 MgO solid plus energy. Did you see how the two substances reacted with each other to form a new substance? See how the precipitates look. For the next activity, the next activity is about lead nitrate solution. It is taking a lead nitrate solution in a test tube and adding potassium iodide solution to it. You will observe in this precipitation reaction, yellow precipitates of lead iodides are formed. The equation for this reaction is PbNO3 twice plus 2Ki gives PbI2 plus 2KNO3. The above reaction is an ionic reaction and takes place between a metal and non-metal. So again, when you observe in this reaction, a new substance is formed by reaction of two existing ones. Let us see one more activity. Take a few granules of zinc in a conical flask or a test tube. Add dilute hydrochloric acid or sulfuric acid to this zinc granules. Handle the acid with caution. It can damage your skin. Do you observe anything appearing around these granules? Touch the conical flask or the test tube. Is there any change in temperature? Now, when dilute hydrochloric acid is added to granulated zinc placed in a test tube, a colorless, odorless gas is evolved with bubbles. This gas is hydrogen gas and zinc chloride is formed which is white in color. So, the chemical reaction for this can be written as Zn plus 2HCl gives ZnCl2 plus H2. Now, on the basis of these chemical reactions and activities, we will understand the concept of chemical reactions and chemical equations. From the above activities, we can say that there are following observations which may help us to determine whether a chemical reaction has occurred or not. Change in state, change in color, evolution of a gas, change in temperature. So, we saw in all the three activities, we could see the change in color, evolution of gas, and change in temperature as well. So, as we observe the changes around us, we can see that there is a large variety of chemical reactions taking place around us. We will study about the various types of chemical reactions and this symbolic representation in this chapter. Now let us see what are chemical reactions. A chemical reaction is a chemical process in which two or more than two reactant, be it atoms, molecules or compound, mixture combine to form a new substance called product. Here you can see the two atoms of different kinds are combining to form the third kind of atom, which is having both the original atoms. They are called as reactants and these are called as products. For an example, when ammonia, that is NH3, reacts with hydrochloric acid HCl gives NH4Cl, ammonium chloride. Here NH3 and HCl are reactant and NH4Cl is a product. Now let us see the difference between a chemical reaction and equation. A chemical equation is a symbolic representation of chemical reaction in the form of formula or symbols, wherein the reactant entity are given on the left side and the product entities on the right side. The first chemical equation was diagrammed by Jean Beijing in 1615. On the other hand, chemical reaction refers to the process where two or more substances react together to form product. Chemical reaction is a process in which one reactant breaks or two or more reactants react to form one or more product, but chemical equation represents the reaction which had occurred by symbol. In short, we can say that chemical reaction is the process which is occurring constantly around us due to the chemical change, wherein two reactants are combined to form a product by breaking of bonds and making of new bonds. And the symbolic representation of this chemical reaction is called as equation. So, we can define chemical equation as the symbolic representation of any chemical reaction is called as chemical equation. Now, there are certain laws to be followed while writing these chemical equations, and you should be aware of certain symbols related to it. The rules are: the chemical equation should be written with the reactants, if there are two or more, should be separated by plus symbol, some applicable to product. on the left side of the arrow and the product of the chemical reaction on the right side of the equation. The head of the arrow should always point towards the right or towards the product side of the equation. Sometimes indicate equilibrium with the reaction proceeding in both the directions simultaneously. A condition required for the reaction to proceed, say temperature, pressure, catalyst, etc., should be written on the top of the arrow. The physical state of the reactant and product should be informed by writing the state inside the bracket next to the reactant and product. If gas, you need to write, for example, O2 into bracket G. Similarly, for liquid L and solid S, aqueous solution AQ, etc. Chemical equation should be balanced on the basis of law of conservation of masses, that is, the number of atoms of elements on the left side reactant should be equal to number of atoms of the same element on the right side product, which you will understand when we do the next topic in balancing the chemical equations. An example of balanced chemical equation following above rules can be seen in combustion of methane. CH4 gaseous plus 2O2 gaseous gives CO2 gas plus 2H2O liquid. Reactants on left hand side and product on right hand side.